All right, so today our goal is to talk about special right triangles. And so this is really helpful because when you recognize you have a special right triangle, then you can very quickly figure out lengths of sides. So let's see, this comes out of lesson 8.4. So we're going to launch right into the first one, who's special, and this is theorem 8-6, and he actually does have a name. He's called the 45, 45, and 90. Now, what's applied is degrees theorem. Okay. So this says in a 45 degree, 45 degree, 90 degree. So if your triangle's angles have these exact measurements. So in a 45, 45, 90 degree triangle, the hypotenuse is radical 2 times as long as a leg. Okay, so we're going to investigate that a little bit. So given that we have a 45, 45, 90 degree triangle, our job would be to prove that the length of the hypotenuse is equal to radical 2 times the length of a leg. So let me draw a picture of our triangle. What kind of triangle do I have? Be more specific. An isosceles right triangle. Okay. So normally when we're talking about Pythagorean theorem, we talk about A, B, and C, where A and B are the lengths of the legs and C is the hypotenuse. Well, we can use C for the hypotenuse, but we're not going to have an A and a B. But because it's isosceles, we're going to see A twice. So if we plug this information into Pythagorean theorem, we would get A squared, or C squared equals A squared plus A squared. And that gives me C squared equals 2A squareds. So then I'm ready to take the square root of both sides. Bink, bink. And we get square root of C squared is C. I can take the square root of A squared as A, but I can't take the square root of 2. So basically, I've just proved that the length of the hypotenuse C is going to be the length of the leg A times radical 2. Okay? So that's one thing. So let's do a couple practice problems of this. So we'll hold on a second. All right, so let's apply. So find the value of x. So remember what I've been talking about since the beginning about theorems. Theorems just give me a faster way of solving things. I can use Pythagorean theorem every time on these, and that's fine. Or knowing this pattern, I can get to the answer much faster. Okay? So we're going to do 2 examples. I have a right triangle, and they tell me one angle is 45. They're going to tell me the leg's measurement is 12, and they're going to give me a hypotenuse measurement of x. So what I do is I remember that relationship in a 45, 45, 90, that the hypotenuse is radical 2 times the length of a leg. So the hypotenuse x is going to be radical 2 times the length of the leg, and all I do is rearrange that. And I get 12 radical 2. And that's your answer for that. It's super simple when it's given to you that direction. Okay? Math gets a little bit more complicated as if I tell you the hypotenuse measurement and you have to figure out the leg. So let's give you another one. We'll make this the 45 degrees. The hypotenuse will be 8 and the leg will be x. We're still going to use the same relationship. The hypotenuse is radical 2 times the leg. But we're going to plug in the numbers. So we get 8 equals radical 2 times x. Now again, a lot of people will put the x in the front because they don't want you to confuse what comes underneath the radical sign. So to solve for x, I'm going to have to divide both sides by radical 2. Using symmetric property, I'm now here. But remember, we had 3 rules about simplest radical form. Number 1, I can't leave perfect square factors under a radical. I don't have that issue. Number 2, I cannot have a fraction under radical. Technically, I don't have that problem. It's the 3rd rule that I'm breaking. I'm not allowed to leave a radical in the denominator. So how am I going to rationalize the denominator on this problem? Lauren? Yeah. It's as simple as multiplying numerator and denominator by that radical on the bottom, okay? Now, what happens is that it may still take you a little bit of time to get to the answer. So coefficient cannot multiply with the radicand, so it's 8 radical 2. Radical 2 times itself. Don't take the intermediate step of saying radical 2 times radical 2 is radical 4, and the square root of 4 is 2. You square a radical, the radicand comes out. So you get 2. Are you done? The answer is no, because you have simplifying that you can do with your fraction. Notice you've got 8 and 2 are outside numbers. You can simplify them. 2 goes into itself once and into 8 4 times. So the answer for x is 4 radical 2. All right? So that's one special right triangle. Let me tell you about the second one. Everybody good? Alexa says everybody's good, so I guess we're good. The second one, again, another theorem. Let's go with Poisson. Theorem 8-7. He's got a name. He's called the 30, 60, 90. Those are all degrees. Triangle. Oh, no, theorem. Sorry. This one's a little bit more complicated because we have 3 different measurements. The angles indicate that. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the short side, or short leg, let's say shorter leg. Let's change that. And the longer leg is radical 3 times as long as the shorter leg. Oh, as long as the shorter leg. Okay. So let's go over what that means. So given is that we have a 30, 60, 90 degree triangle, ABC. And we want to prove that the height, well, I'm just going to, let's do that. There's not really a proof that we're going to do. What we're going to share with you is what this theorem actually says. So notice that you're not going to have 2 legs that are the same length, like we did in the last one, and the angles tell you that. And here's what you need to pay attention to. The lengths of the sides actually tell you the angle sizes. So which leg is the shorter one? The one on the left or the one on the bottom? The bottom. Because he's the shorter one, the smaller angle is opposite him, which makes the longer leg go with the 60, and obviously the longest has to go with the right angle, the 90. So what this one says in the proof, and let's see, let's put my letters. Where do I want to put my letters? Let's go A, B, C. And across big A is the length of little a, cross of big B is the length of little b, and across big C is the length of little c. So according to this theorem, what it says is that the hypotenuse is going to be twice the shorter leg. So according to the way that I've drawn this particular one, the hypotenuse length is C, and it's going to be twice the shorter leg, which would be 2 times A. Okay. The next piece that it tells me is that the longer leg is going to be radical 3 times the shorter leg. So shorter leg shows up a lot. So according to our picture, the longer leg, which is a length of B, is going to be radical 3 times the length of the shorter leg, which would be A. Okay. So let's do, everybody good? So this would be our third example. Oh, this time now we have more than one thing to find, so our directions are going to tell us to find x and y. Okay. So example 3. Here's your 60 degree. Here's your 30, and they don't need to label both of them. If they've labeled one as 60, you know automatically the other one has to be 30. So this is x, this is y, and this is 6. All right, so the one that they give me that's 6, which leg is that? 6 is the longer leg? It's opposite the 30, so it's got to be actually the shorter leg. So they gave me the shorter leg is equal to 6. So hypotenuse is equal to twice the shorter leg, according to the theorem. So that tells me the hypotenuse, which is x, would be twice the shorter leg, so 2 times 6, and we get x equals 12. So there's our first answer. Now, the longer leg is equal to radical 3 times the shorter leg. So the longer leg is y is equal to radical 3 times the 6. So the only thing I'm going to do is rearrange that and put the coefficient in front. So I get the longer leg y would be equal to 6 radical 3. So again, if I know those relationships, bam, I've got answers real quickly. All right, let's do one where it's more complicated, where they don't tell us the shorter leg. So here's our right triangle. Here's your 30-degree angle, which would make this guy 60 degrees. I'm going to give you a leg of 8, a leg of x, and a leg of y. So what does the 8 represent in that triangle? It's the longer leg. So what we're going to do is the two relationships that were given to us in this problem, we want to start with the one that talked about the longer leg. And that was the one that said longer leg is equal to radical 3 times the shorter leg. So the longer leg 8 is equal to radical 3 times the shorter leg x. So to solve this, we're going to divide both sides by radical 3. This gives us x equals 8 over radical 3. It blows the third rule for simplest radical form. We're going to need to rationalize the denominator. What am I going to multiply top and bottom by? Radical 3. Now to conserve space, I'm going to write the answer to the right. So I get 8 radical 3 over 3. Can I simplify? No. So there's your x equals. Okay. Now that I know the shorter leg, I can use the other relationship, where it says the hypotenuse is equal to 2 times the shorter leg. So the hypotenuse, which is y, is equal to 2 times the 8 radical 3 over 3, which gives me 16 radical 3 over 3. Can I simplify that? Really? What do I get? Yeah, 3 doesn't go into 16 as much as we would like it to. And that's the answer to that one. Okay?